Hello and welcome back to the show. I'm Relevant, this is Do. All of the things. On today's episode, Project Jubilee. Back for one last hurrah. I think I'm pretty much done with this guy, so I'm going to run you through a little summary of what has gone on with it, how I like to set it up and use it, and then I'm going to be doing a couple last modifications, specifically adding a Footswitch Buffer because what I did in the last episode doesn't work very well, and I'll show you what's going on with that if you stay tuned. You will. I know you will. So if you've been following the comedy, you know that I built a Marshall Jubilee clone out of half scrap parts, and then I upgraded it with good parts, and I built it into an old Trainer Voicemaster chassis, and it's been pretty freaking awesome. Since I built this, I had the opportunity to test drive a real Jubilee. It was at the local Long and McQuaid, and sure enough, it sounds and functions identical. Now, I didn't A-B them next to each other. There might be slight variances, but for the most part, when I plugged into that amp at the store, it played, it felt, it sounded pretty much like what I have right here. So I'm gonna say that this is completely a success, and it is pretty much a faithful Jubilee clone. Now I have other ideas of where I might want to go with this, especially officiating the mod, but I'm kind of not in the mood right now, and this works so well as is and has so much just dripping with character. It's just so interesting. I'm probably just gonna leave it like this for the next little while. So I don't know when I'm gonna have another video about this. But either way, what is its final form? This thing has a slightly blueprinted ground scheme. I'm pretty sure I went over that in another video. Some of this I do not remember what I have and have not filmed about this at the time of filming now. I purchased some cheap generic Marshall silver cap knobs, eBay China. I do quite enjoy them, even though it's hard to see where they're pointing, but that's part of the Marshall charm, right? And as you might be aware, watching the previous episodes, I'm using the original Trainer power transformer, a Trainer choke, but I upgraded it, or I changed out the output transformer with a 1750N. This is a replacement JCM 850 watt transformer by our Canadian Hammond company. And these transformers are actually made in Canada, which actually makes them an excellent deal, and it sounds great with this transformer. I like this transformer, and it might add to the tone. For the tube complement, over here in the preamp section, well, we only needed 3 tube positions, and this amp had 4. So this one right here is actually a power switch for the heater for V1. I have been running a Russian Surplus 6N2P EV in this amp. I have the EVs and the non-EVs. I like the non-EVs in the 800, but this 6N2P EV has pretty much been living in V1 of this amp. I've tried other ones. This one keeps making it back into there, so I think this is the one I like. Acoustically, it sounds similar to the Sovtek 12 AX7WA. The plate structure is even similar. I think that Sovtek tube might be a modern iteration of this, and this is what allows me to accommodate it. The heater pinout on these tubes is a little bit different. The arrangement that the 12AX7 has is known as the 9A. I guess 9A is the socket pinout configuration, where 4 and 5 would go through, be 12 volt heaters, and then the center is what taps them and allows us to run it at 6 volts. We put half of 6 volts on these two, 6 volts on there. We end up running these in parallel. The 9AJ, which is what the Soviet tubes use and some other higher end preamp tubes, the pin 9 is a ground shield. And 4 and 5 are the sole heaters, and they're permanently wired in parallel. So that's what this thing does. This thing switches between 9A and 9AJ. So 12AX7 support here, Soviet support in that position. There are various tutorials online showing you the differences in wiring and even how to add switches to them. But we do it one up, because when we switch to the 9AJ configuration, it will ground out that pin 9. Phase inverter is stock and is tube, and I'm currently using a Tungsol 12AX7, which you all know is one of my favorite phase inverter tubes. Sometimes I like the Sovtek 5751 in there. Those are just my 2 favorite phase inverter tubes. The big controversy is the second position here. In a previous episode, I built this substitute. It's basically a 12AX7 socket saver, and I crammed a couple LND150 MOSFETs in there. I did a video about those things where you could pretty much just drop in substitute a preamp tube with these LND150 MOSFETs. In some cases, it will add to your sound. It will change things in good ways that you might like, and in other cases, it sounds like arson. In this case, I tried the substitute in position 2, and I loved it. It is the epitome of tone on this amp, and it has been living there ever since. Anytime I put a normal tube back in there, I've ended up swapping out, putting this guy back in there. And you might wonder, how does this affect the sound? Well, in purely a good way if you know how the Jubilee circuit works. V1 is these two positions right here. And this is your actual preamp gain stages, your actual distortion generators. This is what's creating the preamp gain along assisted by the clipping diodes. The clipping diodes are a huge thing in this amp and how it works. V2 that I've substituted is these two positions over here. And if you look at how they work, this has something known as local feedback. And that is actually for controlling the gain or preventing distortion. I forget how to explain what it does, but a gain stage with local feedback is not there to generate distortion. Quite the opposite. That's used more in hi-fi applications. And then this one here follows up the effects. Typically, a tube right after your effects loop is also not generating distortion. The fact is, I found in testing, this is just simply a mixing buffer effects loop send in recovery stage. That's it. That's all. If you change out this tube, your distortion characteristics don't change. The amp just gets quieter if, say, you put a 12AU7 in there. And in this case, because these substitutes got some cojones to them, the amp got a bit louder. You know, say what you will about solid state versus tube. The LND150s, their highs go higher, their lows go lower. They have a cleaner sound, which is why they suck for generating distortion, why you're not going to want to use them in some of these other positions. They take away that tube character. But when you're just trying to buffer a signal and then re-amplifying it, it's perfect in this. So if I was going to clone this amp again, I wouldn't even have a second tube socket. I would just hard bake those LND150s into that position and call it a day, and we would only have two tubes. Now you might say, well, if it's that good for that kind of application, why don't you have it in the phase inverter? I don't know. Just sounds better with a tube phase inverter. It just boils down to results at the end of the day. For power tubes, I've been using Sovtech 6L6W XTs, which is funny. These are a nice little rugged workhorse tube. I like to keep a set around, but there are very few amps I actually prefer their sound in until I got this one. This is one of the few amps that I actually like the way the WXTs sound in it, and they have been, again, I've tried other tubes. These are the ones that seem to keep finding themselves back into this amp. On the inside, if you're not aware already, my red light here is MOSFET controlled there. Just like on the Jubilee has a little red LED for the lead and rhythm channel. That's what that does. I have a switching metrics here, and unlike the Jubilee, I have foot switching on the clip too. So I foot switch both channel and rhythm clip, and I believe that's an important feature to have because turning on the rhythm clip when you're on the lead changes the sound. Over here in the general preamp area, when you are in lead mode, this is a ground point here and it grounds out the rhythm section. But then you see you have clipping diodes here. Those are the rhythm clip. That's the rhythm clip switch. And then we would also have a ground path coming this way to the switch. Now we have signal for the lead channel going this way. And then there's a connection junction point here. Now with the rhythm clip switch off, the signal can pass down here and be affected by that capacitor and that resistor. And that is common RC tone circuitry. It does have an effect on the tone. Actually kind of beefs it up a bit. There's a mid boost when that turns off. When this is turned on, there is a ground path grounding out the bottom of this resistor, disconnecting and validating that capacitor, and that of course naturally is going to have an effect on the tone. It actually gives it more of a mid scoop. If you find the amp's dark, pull that, it'll smooth it out a bit. So both tones are pretty good. At the end of the day, you could rhythm riff out with rhythm clip on with that flattened tone, and then when you punch rhythm clip off and get that mid boost, that would be good for a solo. So I think that should be foot switched. It's foot switched in here. And sure enough, when I was testing the amp at the store and I turned on and off rhythm clip, it did the exact same thing. It's not a glitch specific to my amp. The real Jubilee seems to do it too, or at least the reissue I played at the store. Now, in a previous episode, I arranged a foot switch for it. And I thought it was a pretty snazzy idea. I wanted to put the LEDs in there so we know the status from this, especially for the clipping. There's no light on the Jubilee that tells you if the clipping's turned on and off, so that's a bonus. and I was gonna have this whole rigmarole way of doing it, but at the end of the day, all I did was put it in series with the relays. So I don't have it schematic or draw out here. You're gonna have to take my word for it. Positive, for example, will flow through a relay then to the switch. In the switch, it goes through a resistor that biases the LED, and the LED is connected to ground. There's not enough current being pulled by the LED to fire the relay until we ground out that LED via how a foot switch works, and then the relay fires. However, I found in practice it doesn't work well, especially with different tubes that cause different voltage drops in the heater circuit. So if you look here at front of amp, if I clip the channel switch, we see this light comes on and off. That light's hooked up to the relay in such a way that the relay is controlling it. So if the relay wasn't switching, that light wouldn't change. And then, you know, we touch the rhythm clip and there's no light to indicate that, but it is working. If I turn rhythm clip off and then turn channel off, light goes out. But with rhythm clip off, if I press the channel button again, that light lights up, but this doesn't. The relay is not firing. For some reason with this turned off, there's not enough, like, it's holding the relay on. When that light's off, the relay's energized. So I don't know, I haven't actually tested it. I just know that it's not working, and I'm gonna be changing it today. So one of the two final mods I'm doing to this amp is I'm actually going to build a Footswitch Buffer, kind of like, you know, I did in the Jet City, except not with an op amp this time. I'm gonna be using an inverter. I have a circuit prototyped here. I had to use leads for other experiments since I put this together, so I'm not gonna demonstrate. I'm just gonna build on it. Now, when I set up the foot switching on this, I was so proud that I got it to work against ground. So basically just chassis grounding out those connections fired the relays. It's because I worked on a 3-volt specification. It's using the power from the artificial center tap to fire the relays. For this buffer, I just decided to go with a 6-volt system using a isolated jack. So it's gonna have a ground lift. I actually initially designed it with the 3-volt system in mind. The problem was, the 3-volt system, I didn't like the amount of light that I was getting. The LEDs were too dim. Here's a schematic of the 6-volt system. So we have our 2 heater connections here. It gets rectified, reservoired into this capacitor, and then there is an inverter, a 74 LVC 2G14. Now, our positive rail goes through this 220 ohm 1 watt resistor, then down to the foot switch. This goes through this 470 ohm and powers the LED. When we flick the switch, it grounds out the LED arrangement, pulling this junction low, which puts a load on this resistor, and that tells the inverter what to do. So when the LED is active and that switch is open, the inverter is seeing positive at this junction. It's seeing high at this junction, and then it will put a low signal out at its output, essentially ground or negative, and then the LLA LED for our solid state relay has ground on the other side or negative on the other side. Seeing negative at both points, it does nothing. When we ground out the LED arrangement, this junction sees low. The inverter will put out a high signal, which will fire this LED and activate the solid state relay and activate the attached relay. And then we just have that times 2. Now, one problem that you have designing this is, well, when you ground this out, this resistor becomes the whole of the load. This circuit with this heater is giving me 8.5 volts after rectification. My resistor here was dissipating about 1/3 of a watt. I could lower that value down, but my LEDs would start to get more dim. Even at a 330 ohm, I was getting just under 1/4 watt, not within my 80% D rate. So these are 1/4 watt resistors that I've typically used to build these little circuits. I was getting just over 200 milliohm, and you want to D-rate everything, right? So if you have a 1/4 watt resistor, 250 milliohms, multiplied by minimum 80% D rate, that's times 0.8. Then as soon as we exceed 200 milliwatts, we need to step up. That's just good electrical design. You always D-rate, right? 220s gave me the sweet spot for LED brightness and didn't dissipate too much current, because that's the thing. This becomes a load at 8.5 volts divided by 220 ohms. That's 38 milliamps. In order to get the 3-volt system to work, I'd have to go down to 47 ohms in order to get the brightness that I wanted, and then they would just start dissipating too much wattage, like 100 milliamps. In this case, I'm using 1 watt resistors. I had in stock these little, I think they're Vichy Dale CPF 1s. They're little 1 watt dealies, about the size of a 1/4 watt, they're gonna do nicely. Now for the logic chip, I'm using a 74 LVC 2G14. That's LVC, low voltage CMOS. So it's almost identical to the HC series, but it's lower voltage. And the reason why I did this, a little hackery, because you see these LEDs and the LLA solid state relay, they obviously need some bias. We can't run them off 8.5 volts. These guys are so efficient, they can fire almost completely this relay at as low as 2 milliamps. I like to shoot for 3 to 5 just to be safe, because if there's a voltage dip, well, you're gonna get a half fire. They can operate as high as 20 milliamps like any other LED, and I think they have a max of 50. A 1K resistor is giving me about, well, let's see, should theoretically be giving me about 8 milliamps, 8.5 milliamps of dissipation. I think in practice I tested it anywhere between 9 and 12, and that's going to be our total dissipation because I did a common bias here. This is going to dictate the voltage for both of these. So one will get more current if I'm only using one. If I activate both circuits, it'll split the difference, but it's still going to be well within their operating threshold. And that's why I use the LVC, because the voltage drop that controls these LEDs is going to be incurred by this resistor. And I tested at this junction, powering in here, 1.2 volts when these guys are fired. And the LVC has no problem functioning correctly off 1.2 volts. And if you know how logic circuits work, the output is active. There's no low impedance, there's no off state. It's either connecting the output directly to ground or connecting it directly to positive. So when it goes high, it's basically powering through positive, and then that's our voltage drop. We have our typical 0.1 capacitor here for stabilization, and I actually added a 5.1 volt Zener diode to clamp the voltage, because the thing is, if neither one of these LEDs are active, this junction point isn't going to be seeing a voltage drop. The LVC, its quintessence current, does not consume anywhere near enough current to actually incur a proper voltage drop across a 1K resistor. So we would see a spike basically all the way up to our V plus rail at this point. That would fry the LVC. It has, you know, a 5.5 volt max. So this clamps it for when these circuits are deactivated. And fortunately, the current drop across a 1K resistor is so low, this 400 milliwatt Dealey Zener diode here isn't being stressed at all. Yes, I know, it is actually a 500 milliwatt, but again, 80% D rate. When I'm using Zeners, I design the circuit based on 400 milliwatts. Some data sheets will even tell you to do that. Pretty straightforward, stupid simple circuit. It makes my previous design where I used a voltage comparator op amp look like frickin' Stone Age, and sure enough, it works well. So let's build on it. Here is the PCB layout I came up with, all to fit onto this tiny little 2x8 perf board. Now I had to drill some holes here to fit this particular component. It's an Amphenol ACJS PC mounted stereo jack, and it's going to be electrically isolated. The outer positions pretty much line up with the perf board spec, but the center position is kind of in between, in limbo. We're going to have our power com going there. There's our reservoir cap. There's our LLA solid state relay inverted. Actually, both of these are kind of backwards. 1K Zener diode are 220 watters, and there it is. And then there's where we're going to hook up our switches. Our switches aren't going to be powered off ground anymore. Well, let's fast forward building the actual thing, bud. And here it is, in all of its basicness glory. Wow, 2 capacitors, 3 resistors, 2 diodes, a jack, an SSR, and a logic gate. But not actually a gate. I've gone ahead and pre-connected the power that's going to connect to the heater circuit and also the ground. I just have to connect the relays and the switches and get her installed. That all goes into this general area, which I'm going to have to dismantle. Ugh. You do such a good job installing stuff, it's hard to uninstall it. Question is, will I be able to repurpose these switch wires Oh, ho, ho, ho. Is this a loop through? I think this is a loop through. Oh, it's totally a loop through, isn't it? Oh, me and my dirty tricks. Yeah, a loop through is you mid-stripped it and I put it through the hole and then I connected it up and, you know, it makes for a really nice clean install, but pain in the arse to get out after. All right, where's our little module? The idea is our module is gonna slot in underneath these switches and through the hole. And then it's just gonna fit right there underneath the switches. And I space it out to make room for the cap and the tall boy. That lead's not gonna reach to where the switches need to connect. None of these leads. I'm gonna have to put new leads on the switches, I guess. Problem is, these switches, they're starting to get over it. A little overworked. This one doesn't even have a loop anymore. This looks like its loop's about to break off. Okay, I'm having ideas, sir. Now, the jack has these nice holes here that we can use as just straight up terminals to put the wires through, instead of having to cram through little perf board holes. So that's somewhat convenient. Huh, which channel's what here? We have a white wire. Might have to fire up the amp very briefly to get power to remember. White is rhythm clip, black is channel. All right, remember that. Just gonna like widen these holes so the old wires get through them good. Might as well solder down this jack since I'm not going to be soldering to the bottom of it. Oh. You went right through the board, eh? All right, switch lines. Okay, can we get this thing into place now? Oh, you know what's wonderful? I just remembered I forgot the 0.1U decoupling capacitor because it wasn't in the schematic. Nice! It would go right on the positive and negative terminals. I would actually poke it right through the holes and use it as the leads. Why did I have to notice now that I forgot that? My retentive side couldn't stand that. I managed to half-arse it in there, so crisis averted. I'm gonna put Mr. Chippy in here before I forget. I'm gonna mock this up. I'm gonna try to size out our lead wire, our power lines. They have to come right about over to here, then about this. Should be good. Run these down and along the back. Come on, keep going. Keep it going, bud. Come on. Come on, you can do it. Go on. Oh, bud. Go on, bud. All right, where's one of those black bands? So we've snugged it up. One thing you gotta watch out for this guy is, you know, it's pivoting on this point. So it could, like, swing down if it comes loose, and the power here will short out against the chassis. So bear that in mind. Or, you know, this is my amp. I doubt anyone else is ever gonna do this way, so I'll bear it in mind. I want to get them switches hooked up, channel and clip. This is the home stretch now. This one's will be clip. This one will be channel. I just have to get this ground bus across, which we'll just sloppily tack into place. It's just a buffer signal anyway. It's not going anywhere. This is all assembled now. Nice. And it's a little up tilted. Oh, it's having a hard time moving. That's a good sign. That capacitor's making contact with that grommet. A little bit of glue right there might go a long way. Stop that thing from ever pivoting, but she fits. Just gotta get them power wired. This is going to be heater supply right here to a little bit of a DC rectifier that runs the relays. So just tapping on that. All right, so those are gonna be just about the right length. Aside from this ground line, we need to separate it off elsewhere. We get these wires through these holes. Schnattered them down. And our circuit should have power now. Yeah, we just need ground. Now, I didn't want to pull ground from the audio circuit up front. I wanted to come back here to the general, you know, main area. And I was thinking, you know, I'm just gonna tap ground off these capacitor bar here that pretty much connects over to the main star ground. That should work well. Yup, we'll just tack that onto that bus bar there, and she's gonna be all connected. Okay, it should be ready to roll. Just we have to make an adjustment to the switch first. Because if you remember, the way my relays are hooked up there, you know, one's on the positive of the DC phase, one's on the negative DC phase. They both reference the center ground. That's how they get their 3 volts. Which means in order for this to work properly, I had to put the LEDs in opposing phases. The one that's in an opposing phase is likely not gonna switch, and even if it does, it's not gonna light up. I gotta remember which one it is. It's the Clippy. It's the Clippy light. All right. All we gotta do is rotate this pupper around. This could be good. In retrospect, I kind of wish I went with red and orange here, but I had a surplus of greens. You know what? Screw it. We're gonna redo these LEDs. Set aside this green guy for another project. I'm gonna go red and amber here. Or you know what? Yeah. Ah, crap. Which side's which now? And red lead. Red lead. I am low on these. I'm gonna have to order more. Red is such a popular color. I know I'm fond of it. Oh, I see how it is. All right, the LEDs are all phased up, properly maintaining standard wiring. This foot switch should work proper on my Jet City now, and any other amp that takes a dual foot switch with LED indication on it, assuming they went with this standard way of doing things too. And so on now, if you divert your attention down to amplifier, and we give it some 6 volt some power, and then we press buttons, red light, red light, red light, red light. And then, well, the clipping, we can't hear it unless we're actually, playing the amp. But if we put an ear down, hold the switch away. Oh yeah, I hear the relay popping. Yellow light, red light. And they are appropriately bright now. Not gonna have problems seeing that, you know? If you have dim LEDs, you might have trouble seeing them under stage lights. Not that that's a problem for me. I'm not playing guitar live anytime soon, sir. But yeah, how anticlimactic is that? And it pretty much doesn't matter now. It's just gonna work. Now that said, I'm not done with this yet. There is one last modification I wanna do to this thing before I put it all back together once and for all. And that is come to my attention. Hey, my eyes are up here, bud. That I am over the novelty of the whole reaching around back to turn the power on. I've already done a modification to the effect to the other amp, a custom special. This is the power switch now. I want this to be the power switch. I'm over this reach around. Fact of the matter is I don't use my standby switch. I only use it for service situations. Like if I want to hot swap a tube, or I'm working on it like this where I just want to get some power to the heaters real quick. If you read old technical documents back from the golden era of tubes, they tell you don't need standby on receiving tubes. That's the general name for tubes that are in radios and amplifiers. They're receiving tubes. There are tubes in human history that do need to be preheated, but they're not receiving tubes. We're talking about massive transmitter tubes, and there was this one that I was looking at one day. Was it a Barretter? No, it wasn't a Barretter. I think it was some weird regulator rectifier tube, something. I can't remember, but it said absolutely you need to let it warm up for like 10-30 seconds before you apply power to it. In actuality, for receiving tubes, it can be bad to do standby. You know, you got a power supply that's ready to go, and then you inrush current punch them puppers. I don't know that they like that. Turning the amp on and off is a natural soft start. As the tubes warm up, they let more power flow through them. One thing's absolutely certain, it is recorded in the annals of tube design. You don't leave tubes on standby with the heaters hot. They are not designed to be hot with power not applied to them. I guess it's okay if you just want to do quick switch-a-maroos, but you shouldn't be leaving them on standby for long periods of time. At the end of the day, I turn the amp on, I play it. When I'm done, I turn the amp off. Not interested in standby. So I'm gonna move it to the back. I'm gonna keep the standby. I'm just gonna move it to the back. And I'm imagining that we gotta start digging up into here because these wires are gonna become invalidated. Heck, there's this little one here. I don't know if I'm gonna be able to unsolder that anytime soon, so I might have a floating ground. Actually, I know what I'll do with it. I'll tack it down to one of these established ground points. It will incur just the slightest ground loop, but not one that I think we need to worry about. Because right now, this is our chassis ground. This is all our ground chassis. That's just bolted on there. Some might say that that's bad form. I think it should be okay. But if we solder her down here, she's got a hard connection now. Now the standby switch and the power switch appear to be relatively identical. So I could probably like not bother unscrewing these things and just move the wires around. Have I ever disconnected mains on this thing before? I got two things on this wire here. This is going to be a pain in the arse. I need to rotato this around. I don't know how well you're going to be able to see what I'm doing here. There is this jack, this power port here, and it's switched, and I'd like to maintain that because what I'll often do is I'll have an AC adapter parked in there that turns on and off an overdrive pedal as I go to use the amp. This wire here, am I not able to get that? I might actually be able to get that right front center all the way over to here. I just have to reroute it. Working on these jacks, it's a pain in the ass because they just have these tiny little solder points in there. Actually, it's kind of large. I might be able to leverage that. My fuse holder is a bit upside down here. All right, an 18 gauge rated wire. I only have this beefy green in stock. That's okay, as long as I know what it does. It's going smoothly so far. All right, we run this around the circumference up to about frontwise, yeah? Have to accurately estimate the amount of wire we need. And with this, we have power to switch. All right, power from switch now, all the way back to, it's got to go to the power jack here. Appears roughly right there. Now we gotta do a little bit of contortion here because we gotta get the transformer line in there too at the same time. In order to do that, I might have to polish up this wire. I hate chopping down the original wires because they're already kind of set to length. And you can't get that back. But on the power connector here, we have a relatively large size hole, which is fortunate because it means we should effortlessly be able to put both these power lines in there. The one that returns from the switch and the one that's going to the transformer. So we're gonna have switched power there still and acts as a connection point. That should do. Except for one problem. I'm noticing that this contact is brass and this contact is silver. Yet, the neutral's on the brass and the hot's on the silver. That's backwards. However, from the looks of it, I never moved that neutral line. That is the original spot of it. Oh, and the jack's polarized too. Really? Yeah, really. It's phased backwards. I never noticed that until today years old, bud. For furk's sakes, you furkin' cause you know I can't leave that be. Ho 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 ho. It sucks having standards sometimes, bud. Get out of there. Fortunately, it doesn't look like it's gonna be that hard to work on. I just gotta undo what I just did. While we're at it, we'll use this opportunity to get rid of this crap here. Just, yeah, done deal. Except this transformer lead barely reaches. That's probably one of the reasons why it was done that way. Nice. It will though. It'll come very close to the ground line, but let's see. It's a little bit firm, but it does reach. Okay. Now to get that wire in there. This wire is entirely too big to begin with. Who friggin' thought they needed a friggin' 14 gauge? You know, that's something I want to replace, but I can't justify doing it because it's like, if it ain't broke, don't fix it. Okay, this is a bit of a contortion. I gotta use my finger to hold the wire into place while soldering on it. It's not going as nice as I'd like. You know, the second, oh, my finger's dirty. All right, now let's get our theoretical positive into place, even though it's not really positive or hot. All right, there's gonna be a little bit of UG factor, but it's wired up properly. And this wire, it's got enough slack. It's not taut and under tension, but yeah, done deal. Now I just have to get the new standby set up. And to do that, we need, how does this work again? It grounds out that, and it grounds it out, ideally, to here. Well, that'll be convenient. We'll just use this. Yeah, we'll just use that ground bar. I have specialty wire for that. It's 20 gauge, not the normal 22 gauge. 105C rated 600 volt insulation. I'm gonna fly right through this one. Get that shotted up there, sure. You know what occurred to me? This is an opportunity to stand by correctly. Nah. Let's hook it up the same way it was. A ground cut. My kingdom for some auto strippers that do not suck. No, it's not worth it that much to me. I can just go buy some. All right, we are connected to the ground bus via capacitor terminal. Oh no, I'm gonna need more of this wire. I don't even feel like I used that much of it. All right, home stretch. Get this ground wire connected to there. Oh, you just want to pop out, don't you? Aha, that should be it now. That should be it. Wow, you know, it is just so interesting in here. All these wires going everywhere. Yes. So now the power switch and the standby are right next to each other. Power switch as in power level switch, 2550 watts. This thing should work. Complete burst power. Yes. There's no power tubes in it, sir. Now, finally, suppose I should get a guitar and dry it out, right? Yeah. Let's pull over speaker line. No odd noises. Let us plug in a guitar. Let us plug in the switch of foot. she's good, sus! So that's how come pics get lost. I've been chucking them this entire time. Well, I guess for now we may say goodbye to the Jubilee. Well, I'm not saying goodbye to it. I'm putting her back together. She's going into the amp wall, and I'm gonna play on her sometimes. You guys might not see much of this amp for a little while. I have no clue, but either way, I hope you enjoyed this. If you did, stay tuned, because sometimes I like to do things like this. There's still individuals out there who are asking me, will you work on my amp for me? And to which I will say, well, sure, yes, might as well. And I'll film it, and I'll post it here, and now I'm just rambling. Give her. Ugh, I went looking for my pick. I tossed the frickin' thing, didn't I? Oh, boy.